All right. So let's see. Shut up. So last time we were looking at array lists, right? So we talked about kind of some upgraded collection types, and we talked about generics, I believe, right? Let me get our project open. All right, so we said that a room is going to hold a collection of exits. And the way we're going to represent that collection of exits is in something called an array list using the generics exit. So that tells us the thing that's going to go into the array list is going to be an exit, which also means the thing that we pull out is going to come already precast to an exit. Things won't come out as generic objects that we then need to turn into whatever they might be. We also introduced a new Boolean operator called the Instanceof Operator, right? So Instanceof Operator allows us to ask, is a particular instance an instance of one of these classes? All right, so it lets us do those things. So let's finish fleshing out our objects here. We had our design for our, we're creating this, which is going to be a collection of rooms with exits. So we decided a room is a name, a collection of exits, and a current player. So a room may or may not have a player in our initial stab at this. And right now, I don't think we wrote any constructors in any of our things. So we'll go ahead and do that for room. So here's the three pieces of information a room is going to manage. And then we'll go ahead and write a constructor for this guy. So the constructor for room will take in probably the name of the room. So we'll create a room like this will be S118B, that'll be S120 down the hall, something like that. So when we first generate a room, we're generating it with a name, but then we're going to go ahead and initialize these other values. So we'll say this dot name is equal to name. That's the value that was passed in. And then we'll also go ahead and say this dot the exits is equal to a new array list of exit. So at this point, if we look at it up here, this guy is a variable called the exits of type array list, but it doesn't actually have a value yet. It's just an empty bucket capable of holding a value. This is where we actually put the value into it. Truth be told, you actually could have put this up here. You could have done that. I would say that's not great programming practice. Typically, when we think about the job of a constructor, the job of a constructor is to initialize values, initialize this object. So the idea is when we think about our fields here, these are the things that we're going to keep track of. And I'm going to go ahead and get rid of that empty room thing that we had last time. That was just for us to mess around with our array lists. So these are the three pieces of information a room is going to keep track of. To build a room, just tell me what the name is. I'll go ahead and set the name. Then I'll initialize my array list to be an empty array list, but it's actually now an array list. I've stored a value in that variable. Similarly, I'll go ahead and say this dot current player is equal to null. There is no player in the room currently. All right, so that is our room. Now we probably will also go ahead and give ourselves a display method so we can ask a room to display itself just for testing purposes. So we'll say public void display. And maybe we go ahead and we do something like system.out.println. And then we do something like, so I'm kind of doing this like MUDs typically do. Also here, I'll just do that as a print. If this dot current player is not equal to null. If I do have a current player, then I'll go ahead and put that person's name in there. We'll presume we're going to give ourselves a get name. So actually, let's pause right here and flesh out player a little bit, because now we're trying to call upon some abilities of our player. In our design, we decided a player is just going to have a name and a current room. So a player is going to have a name and a current room. We'll go ahead and write the constructor here for player. And we'll have a player take in initially the name of the player. And then we'll set current room equal to null. So when we first build a player, it's got a name, but we haven't put him in a room yet. Now, since that field is private, inside of room, I can't say something like this. If I want to, if I'm going to, this is kind of like what a room looks like when it displays itself. We're going to say like room S118, then also here, maybe it'll say Mike if there's a player currently in the room, or it'll say nothing if there's not a player currently in the room. But in this case, I'm asking the question, if there is a player in the room, then go ahead and put that player's name out there. And we might want to get the name by saying current player dot name. Now, we know that this guy must be a field. We don't see parentheses. All right. So it can't be a constructor or a method. We presume that it's an instance field, a non-static field, because we're calling it using an instance of a class. All right. So if we jump into player here, we see, okay, yeah, it's non-static. We don't see static out front. It is a field, but we have an issue. I can't just say dot name here because name is set up as a private variable. I cannot directly access it. So remember, private means we can only access this variable inside of the class called player. I'm trying to access it inside of a class called room. So what we would do is we would give ourselves a getter, a way of giving ourselves public access to a private field. But this gives us only read-only access. That way some external entity can't change our player's name. Go ahead. Yeah, it'll scream at us. It'll say, so if I run it just as it is right here, it's going to say that this variable is not visible because it's set as private in the other. So I'm going to go ahead and inside player, I'll just give myself a function that'll return a string. I'll call this guy get name. You don't have to call it get name in order for it to technically be a getter. A getter is a method that gives yourself public access to an internal private variable, private field. Just typical naming convention is you name it get followed by the variable name in camel case. So the name is capitalized, the G is lowercase. That is in no way required. That's just convention. All right, so I'll make this a public method that returns a string called get name, and he'll return this dot name, where name is private, but I am inside of the player class here, so I do have access to this here. So that's my way of revealing a private field to an external entity. So that's the way we'll get the player name out here. We'll call that player's non-static public method called get name, which returns the string. And in this case, that string is the internal private field called name. else, I could either just kick it down the line or actually, I'm just going to do that. There is a version of println that takes no parameters and literally presses enter. You could also just put out there the empty string. But println will press enter at the end of the line where originally I just said print. So it'll say also here, space, and then either the player's name or nothingness. And then lastly, we have maybe obvious exits. This is kind of like how MUDs usually look. So we'll do a system.out.print obvious exits. And then what we'd want to do is we would want to go through our array list of exits, getting the directions leading from this room. Okay. So we'll write that logic here as we flesh out exits. Right, so player, we look like players in pretty good shape right now. Looks like rooms in pretty good shape, but we're up against the wall here where we really can't do this loop yet. So I want to go through and I want to do something in this loop. So for int I is equal to 0, I is less than this dot the exits dot size. That's the number of elements in there. I plus plus. So for each exit, we're going to maybe build a string that is all of the exits leading out of this room. That's kind of what I want to accomplish in there. We kind of still need to figure out the how we're going to accomplish that because we really haven't fleshed out exit yet. So we don't know what exits are going to exactly look like yet. So that's got to be hold on, we'll write this soon. So now let's go in and let's start fleshing out exits. This was our picture. We had a couple different things we could have done with exits. We can have exits exist one time. Our exits in this picture, these little yellow diamond thingies. So in any case, you could have a single exit that's like a two-way door, or you can have one exits being one-way doors and just have two exits in every room if you wanted to. We're going to do what we did last semester because that's a little bit more algorithmic. We get to kind of ask some if statements and things like that around it, where we're going to have a single exit hold two different directions. So it'll go both directions. So there's an exit in this room that leads out to the hallway, and then that same exit is also represented in the hallway, which leads into this room, different destination. So we'll go into exit here. Go ahead and build our constructor. So in exit, we're going to keep track of two different destinations and two different directions. This direction is going to be associated with this destination. This direction will be associated with this destination. We could even make the argument of, oh, we should just create another object for like a room direction pair. We could do that. And then we just have two variables in here, maybe called like a, I don't know, a room collection or something like that. But we don't need to complicate things now. We only have two things to, well, four variables to manage. So we'll say public exit, and we're going to need to build that door right there, for example. We're going to need four pieces of information. We're going to need the two rooms that are involved, and then also the string direction that we want to associate with each of those rooms. Make sense? That's what we need to, in real life, if we were building that door, you know, those are the pieces of information we need to, where are we going to put the door? We're going to put it between this room and that room. You know, I'm not sure we necessarily give that door a direction name, but we kind of use our vision and decide just head for the door. But we could come up with a cardinal direction-ish for that door once we figure out where the lake is relative to, that's the lake, right? Yeah, so that's south door, southeast. corner, door, something or other. All right. So we're going to have to take in all 4 variables here. So we'll take in a room, destination 1. Then I'll take in I'm going to go ahead and do the room followed by the direction that leads to that room. In fact, I'm going to rename this 2 strings. So we're going to call direction leading to dest 1. And we'll call that guy direction leading to dest 2. To kind of remind us what those strings mean. So this guy will take in a string, which is that. And I'm going to go ahead and just kick it down the line here. All right, Java does not care if you put that on separate lines. Figure that's a little bit easier for us to read than having it all running off the screen here. All right, so 4 parameters, the 2 rooms that the exit's bridging, and then the directions leading to each of those rooms. All right, so now we want to go ahead and set our variables here. So we'll say destination 1 is equal to destination 1. This dot destination 2 is equal to destination 2. This dot direction to dest 1 is equal to direction to dest 1. This dot direction to dest 2 is equal to direction to dest 2. All right, so we'll go ahead and set that up. So that's what an exit is in its most trivial state, let's say. So now going back to our room, where we're trying to display all the exits that are currently in this room. So if I imagine I'm standing in the middle of this room, I'm going to look at my collection of exits, right? So I have my array list here. That's my collection of exits. And I want to find out all of the rooms that lead away from me, right? I know I'm involved in all the exits. Okay? If I'm in this room, from some other room, you get into this room through one of my exits. But I don't want to know that direction. I want to know the direction leading away from me, the destination leading to another place. I want the name of that room. So I need to be able to go through here and ask my exit, given me, I'm a room, tell me what direction leads away from me, leads to the other guy. Make sense? So we're going to write an ability in exit. Get direction string leading away from room. I know it's a little bit verbose, but that's effectively what it's doing, right? I'm going to have a function here that's going to return a string. And I'm going to name it get direction string leading away from room. And I'm going to give it a room. So I want it to return to me the string that is the direction that leads to the other guy, the guy that's not the room that was passed in. So this is just an if statement. If this dot, what do I call it? Direction of destination. If destination 1 is equal to R, then I want to return this dot direction 2. The other guy. The room leading to the other guy. Remember, direction leading to dest 2 is associated with destination 2. So if the room I'm currently in is R, and that room happens to be destination 1, I want to get the direction leading to the other guy, because that's what these strings are going to represent. That's why I named it so verbosely here. This string is the direction leading to the other destination, or a destination. Else, return this dot direction leading to dest 1. So this guy will return the string leading away from the room I pass in. And this is a non-static method, which is an instance method that belongs to the exit class. Inside room, I have a collection of exits. So I want to build up a string So we'll start off maybe with a string called exit directions. That's the empty string. And I want to go ahead and say exit directions is equal to whatever exit directions is currently equal to concatenated with. Now I want to get the exit at bucket I in my array list. Now, in case I don't remember, I'll go into my documentation here. I'll just look up array list Java. And I'll go and browse the functions. One of them is called, I think it's just get. So here's get. I give it an index and it returns the type. In our case, the thing that's in this array list are exits. It'll give me the exit that lives at that bucket in my array list. So I'm going to ask my array list, this dot the exits, to get the exit at bucket I. This for loop is going to take I on a voyage between 0 and the number of elements in exits -1. So I'll ask, so this guy right here will boil down to the exit that lives at bucket I. And then I want to call this dude, long-winded function name. I'm going to kick that down the line here. All right, so I am setting exit directions equal to whatever it's currently equal to, concatenated with, I'm going to put a little question mark in here right now, the direction leading away from a room for the current exit, followed by a space. That way we're going to build up, south space, north space, east. We're just building up a string that we can put after our obvious exits. So now if I'm in this current room and I'm asking this particular exit, the guy that's at bucket I in my array list, to give me the direction string leading away from me. And that function takes a room as a parameter. How do I let this function know about me if I'm a room? If I'm inside of the room class here, how do I let that function know about this particular instance of room? Be this. This is how an object refers to itself from within himself. I'm going to let this exit right here, I'm calling this function of that exit, and I'm going to let him know about this, which is an instance of the room class. Make sense? So I'm going to go through each of my exits and I'm going to say, exit, here is me. Give me the string that leads to not me, the other guy. And the logic for that was just this if statement right here. We took in a room. If that room matched destination 1, give me the direction leading to destination 2. Otherwise, it must have matched destination 2. So give me the direction leading to destination 1. So this loop will build up this exit direction string. So after I've gone through this, I will have built up this string, and then I'll just go ahead and print it out. All right, so now rooms know how to display themselves. An exit doesn't need to do anything other than hold data for right now. And then it needs to be able to kind of reveal a string to the other room other than what you give them. So we taught him one little magic trick. And then a player can't do very much right now. He can give you his name, and that's just in case we actually put a player into a room, which we currently don't even have the ability to do that. I suppose we can do that if we want to make it possible to add a player to a room. We can go into room here, write another function. Called add player. It'll take in a player as a parameter. And remember the fields for room, if I scroll up here, room manages a single variable called current player, at least right now. So we would set this dot current player equal to the player that was passed in. I might also want to go ahead. And we're going to be going in that direction, but then we would need a collection of players. So to an array list, probably. Yep. And actually what we're going to have is a collection of what's called inhabitants, where inhabitants could be players or monsters. That way we can learn about inheritance. Yeah, go ahead. Well, you should. You don't absolutely have to, because right now it would be package level, which is probably not what we want, but it would work. But I would say always make it public, private, or protected. We want this guy to be externally accessible. We're going to say to everyone. When we talk about inheritance, we'll start talking about the use of protected, because really right now we basically choose between private and public. But there is that one where if we don't put anything there, it's actually not an error. It's package level security. All right, so we'll have the ability to add a player, and then we'll go ahead and give the ability to get a player. Since that's a private field, and it's, it's conceivable that we might want to be able to ask a room, what player, do you currently have? Or is there not a player in there? Because we get a null value if we ask for the current player. Because when we initialize the room, by default, the player is nothing, is null. All right, so now we have these objects that have been built that seemingly should work together. So let's go ahead and let's build a room. So we'll build this room. So this is S118. All it needs in order for me to build a room, I just need to give them a string. So we'll go into main here. We'll say room S118B is equal to new room. Now we taught rooms how to display themselves. So I can now ask that room to display himself. This is a non-static public method. So we would say S118B.display. And what does that function do? That function goes in here. It's going to print out the name of the room, which will be S118B. Then it'll print out the string also here. Then it's going to say, are there any players in there? If yes, print the player's name. If no, print nothing. We're going to be in the no category currently. So there'll be nothing for also here, but we'll still have the string also here, just with nothing after it. Then for obvious exits, we'll get that string obvious exits. Then we're going to build up our exit directions. And how many times will this loop go through currently? 0 times. I have built my array list of exits, but I haven't put anything into that array list yet. The array list exists, it's just empty. All right, so this loop will go through 0 times. So when that loop is done, my exit directions will still have nothing in it, and I'll go ahead and print it out. So this is going to print out the name of the room effectively with just a couple of other lines. Oh, double equal sign inside of exit. The Boolean operator is the equivalence operator. Single equal sign is the assignment operator. So here's room S118B. Also here, nobody. Obvious exits, nothing. All right, so now let's build the, I don't know, the hallway. We gave those names last semester, didn't we? So here, it's gonna be hall 3. We'll build hall 3, that room. We'll say room hall 3 is equal to a new room hall 3. So now we have that room. We have 2 separate rooms. Now I'm going to go ahead and build the exit. I'm going to build this door. So we'll say exit, call it E1, is equal to a new exit. Now exits require me to give it the destination and then the direction leading to that destination. All right, it doesn't matter which destination I put in first. I just need to make sure my string matches up. So if I want to say, what did we decide? This is south, south door. So if I want to say south leading to hall 3, I can say hall 3 to the south, and then I can say S118B to the north. So if I walked through that door to the south, once it's installed, it's not installed yet, right? I've run to Home Depot. I've got a couple of instant pop-up tents that we're going to call rooms, and I got this one of those the doors from the back that's really unwieldy to carry, but I haven't installed anything yet. All right, so I've just told this guy where he's going to lead, but now I need to let these 2 rooms know about this exit. Both of those rooms will have the same exit inside of them. So we're going to hand both rooms a pointer to that one exit. So right now, my rooms know how to hold exits, but I don't have any way of adding an exit to a room. So I need to now teach my room how to receive an exit from me. So I'll go ahead and say public void add exit. So we'll have a public function that's going to return nothing. They'll take an exit as a parameter, and we will add that exit to our collection of exits. This dot the exits dot add E, the variable that was passed in. So go back here to main now. I'll go ahead and let both of my rooms know about that exit. So S118B dot add exit E1 no, it's just hall 3 dot add exit E2. And then we'll go ahead and tell the rooms to display themselves. Oh, it's not called E2, it's E1. We built one exit. We're going to let both of these rooms know about that same exit. So from S118B, we have an exit leading to the south. From Hall 3, we have an exit leading to the north. Go ahead. Yeah, so this guy right here, that is an array list, correct? Okay, so I'm going to go and look at my documentation here. We see that, oh, we have an add method that will append something to the end of the array list. And the reason we're using an array list is because it's an elastic thing. You know, we build an empty one and it kind of gives us an initial capacity, but then we could just toss stuff in there as much as we want. And the way we can do that, there's actually a couple of different add things, but the generic one is just like add, it puts it at the end. I could also put stuff at specific indexes. But again, this is non-static, so we need an instance of the array list class to call it. We happen to have an instance of the array list here called the exits. So we'll call his add method and we'll pass it the type of value that this array list was built to hold, which is an exit. And I happen to have an exit right there, so we'll pass it in. Make some sense? Go ahead. And I'll put this up on a link to this up on Slack when we're done, so you have a starting point. Uh-huh. Probably because you did something wrong up here, maybe missing semicolon or something like that.
When I declare public class rules and that first bracket and then I have another bracket around the fields.
He's saying he had too many curly braces. Yeah, so but the problem happened before that. It's not that public is a problem, it's that you messed up ahead of that. So now we'll go ahead and just to kind of put a button on this, we'll assume we're starting in S118B here for no good reason. I'll go ahead and build my player. Player P is equal to new player. What do I need to build a player? To build a player, I need to pass it a name. So we'll call this player Mike. And I'll go ahead and say S118B.add player. So I'll go ahead and put a player in S118, but I don't have a player in the other room. So now when I display these rooms, we'll see that S118 says Mike is here, but the other room won't have that. So S118B, also here is Mike. Hall 3, also here, nobody. Make some sense? All right, so go ahead and save that. So for your homework, and I don't care if you follow this map identically, if you want to build your own map, you can, but roughly build a map about this size. What is this? What, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14-ish rooms. So build your own little dungeon. So using this guy as a starting point. Build a map with, let's just say at least 14 rooms with all of the appropriate exits and directions. With a link, the code, and the self-assessment. And you can just literally duplicate the department map if you want. If you don't want to get creative with this, you can just do the department. All right, questions, comments, concerns, bribes? All right, I will see everybody on Monday. What's up? No. Perfect. All right, so that should be on Slack now. And there's a link to the code.